Okay, the key to this exercise is to recognize where the fulcrum is and where the moving pulley would be and where the fixed pulley is. On this first one, we can look right here, and this rope right here goes around this pulley, comes back, and is tied onto the side of the pole. When this rope right here is pulled down, this lever is hooked to this pulley, and this pulley travels down with the lever. With this pulley moving, that makes this a movable pulley. And right here at this point where it's attached to the lever, this is where the effort force is going to be applied, right here. Because if you look across here, you can see right here there's the pivot point, or the fulcrum. When this moves down, this bar pivots about that, and this cutting blade comes up. So this would be the fulcrum. This is where we'd have the input force. And so the distance between here and here is the effort distance. We have to realize that if we're cutting a twig, the twig is going to be right in here. And so from here to here would be the resistance distance, or where the force from over here is applied. So this would be the resistance distance from here to here. Then all we have to do is multiply the mechanical advantages. The mechanical advantage of here, we have a movable pulley, is going to be, you should have that in your notes. And then we just do the effort distance divided by the resistance distance from here to here, and take that number, multiply by that number, and that is the mechanical advantage of the pruner. I would suggest measuring it in millimeters. If we look at this one down here, when this rope is pulled, this pulley moves with it, which is hooked to this lever, and it pulls down. So this is a movable pulley, and here's the ropes that are attached to that. Right here you can see, and this one when this pulls down is pivoting upon this part. So this is the fulcrum from the center here. If you make the vertical, the direct distance from here to here is the effort distance, and then when this gets pulled down, it pulls on this, and so this is going to be the force applied to this one up here, and so this becomes the resistance distance where it's applying here. So from here to here now is the resistance distance. Now this one, when it pulls down, is pulling on this one, so this is where the effort force is put on. Right here again is where the resistance force is being applied. So to measure this lever, when this is pulled down, it pivots about this fulcrum. This slides up and cuts a twig that's right in here. So the effort distance is the direct line from here, the center here, to here, and the resistance distance is from here to here. Then you put them in the formula for mechanical advantage. Put these distances in the formula for mechanical advantage, and you should know in your notes what this should be, and take this mechanical advantage times this mechanical advantage times that mechanical advantage. One thing that I've noticed in years past, students don't like to show their work. I'd like you over here to show your work so that I can see where you need help if that should occur. Hopefully that gets you off to a good start.